Welcome to our channel. Today, let's talk about creation. Is our world written in code like a simulation program, or are there much deeper laws at play? In 1954, the American science fiction heavyweight Philip K. Dick published a short story called Adjustment Team. The story revolves around the protagonist Ed, who arrives half an hour late to work, a delay that changes his world entirely. Upon hastily arriving at the office, Ed witnesses a peculiar sight. The sun has completely vanished, and the entire world has lost its color. The buildings appear colorless, his colleagues have turned to gray, as if a film reel has switched from color to black and white. Moreover, his colleagues are frozen in place, motionless and lifeless. Ed, bewildered, tries to touch one of his colleagues, only to find that his hand passes through their body effortlessly, causing them to shatter like dust. As he ascends the stairs, each step he takes creates a hole matching the shape of his shoe sole. Arriving at his third-floor office in a state of shock, he finds his colleagues frozen in silent stillness. A man stands by a basin holding a teacup. A typist sits before a typewriter, hand seemingly poised for action, yet frozen mid-motion. At this moment, Ed suddenly hears voices. Turning, he sees a group of people in white coats bustling in and out of the building with equipment. One of them notices him and, astonished, urgently signals to his teammates to quickly bring the equipment, de-energizing, to this individual. Terrified, Ed runs as the white-coated figure chases him with the device. Gray clouds envelop him as he reaches a bustling street. But the pursuers are gone. Gasping for breath, he looks back to see the office building bathed in sunlight, bustling with activity, a stark contrast to what he had witnessed moments before. Confused, Ed stood in a daze for a while, questioning whether he was losing his mind or merely daydreaming. Summoning his courage, he returned to the office only to be met with a scene that terrified him even more. His colleagues' appearances had changed, the boss looked younger, and even the setup in his own office had altered, as if everything had been reset. Shaken to the core, Ed rushed out of the office, intending to use a telephone booth on the street to call for help. However, a more horrifying event unfolded. The telephone booth ascended swiftly like an elevator, soaring high into the sky. Looking down, Ed watched as the buildings and streets rapidly receded, eventually losing sight of the earth. In a state of confusion, the telephone booth abruptly halted, and Ed found himself in a grand hall, where an elderly man seemed to be awaiting him. Ed asked the man if he was dead and if this was heaven. The kind old man reassured him, "No, young man, you are very much alive." He went on to explain that Ed was part of a fine-tuning adjustment, but due to a system error, Ed arrived an hour late and saw the truth, leading to the need for this adjustment. The old man revealed that the white-coated figures Ed had encountered were the adjustment team, responsible for fine-tuning individuals like Ed through de-energizing adjustments. Ed was dumbfounded. The story ended on a cliffhanger as Ed ran out, refusing the adjustment and unsure of where to go. Leaving the old man watching his departure, uttering cryptic words, "You will ultimately return to me. If not adjusted, the outcome will be dire." In this story, Ed exists in a simulated world controlled by electromagnetic energy, where he and everyone around him are merely elements of this energy. The white-coated figures are mechanics sent to correct bugs in this simulated world. While the old man represents the mysterious force controlling this simulated world. Philip K. Dick's depiction of this simulated world is not just a flight of fancy but is based on the simulation hypothesis. The simulation hypothesis suggests that the so-called real world in which we live might be just a simulated appearance, not the tangible, visible physical reality we perceive. In more popular terms, the world is seen as a simulation program, where the universe and everything within it, including ourselves and all our experiences, are simulated by a cosmic-scale computer system created by advanced intelligent beings. The simulation hypothesis can be metaphorically described as humans being digital characters in a game. The white-coded figures are akin to the system's programmers, who can fine-tune each character within the game. If the hand outside of this world were to unplug, without a continuous input of energy, by pulling the plug, everything in the human world would vanish into nothingness. The simulation hypothesis and the currently popular concept of virtual reality are two distinct ideas. People can differentiate between virtual reality and physical reality, but distinguishing between simulated reality and true reality is nearly impossible. Although it may sound convoluted, for most people, the differences between a simulated world and a virtual world seem insignificant. When the simulation hypothesis was introduced, it garnered a following of fans. Dr. Nick Bostrom from the University of Oxford is one such fan. In 2003, he published an article in the Philosophical Quarterly titled, "Are You Living in a Computer Simulation?" Dr. Bostrom's conclusion was that, similar to how it is depicted in The Matrix movie, computers have the capability to simulate conscious human beings, and humans are entirely living within a simulated reality. In other words, upon closer examination, one would realize that all life is a string of digital code, not solid material reality. Astrophysicist Neil deGrasse Tyson initially quite liked this simulation hypothesis, finding its concept very imaginative. He mentioned during an interview with NBC News that he speculated the probability of this simulation hypothesis being true is likely greater than 50%. Tesla's CEO, Elon Musk, is an avid supporter of the simulation hypothesis. During an interview at a code conference in 2016, he made bold statements, suggesting that there's only a 1 in billions chance of us living in physical reality. This implies that we likely exist in a simulated world. Similar to Ed, the main character in Philip K. Dick's novel, we could potentially be de-energized for adjustments at any moment. When a few heavyweights in various industries spoke up, fans of the simulation hypothesis naturally felt delighted and cheered. However, skeptics quickly emerged to challenge the concept. Renowned physicist Michio Kaku, during an interview with Fox Business, smiled and remarked that the simulation hypothesis is interesting and a great science fiction topic. However, he quickly shifted gears and bluntly stated that scientific progress has actually long disproven the concept of a simulated world. Why is it incorrect, you may ask? Kaku explained that based on current observations of the physical world, substances in the universe are composed of quantum particles rather than a string of numbers like 0101. Quantum is a general term for particles smaller than molecules. An important point is that typically the state of quantum particles is uncertain. It is only when conscious humans observe them that their states become determined. In other words, in the quantum realm, consciousness determines the state of quantum particles. Not the other way around, where quantum particles determine the existence of consciousness. This fact directly refutes the idea that computers can simulate conscious human beings. This confuses the creator-creation relationship. Moreover, a more critical point is that quantum particles are not like numbers. They are symbols representing information and understanding. Quantum is a form of material existence that can be continually subdivided. In the 19th century, the scientific community discovered atoms, bringing joy and excitement as people believed they had found the smallest particles of matter. The ultimate mystery of the universe seemed to have been unraveled. However, decades later, it was revealed that atoms are composed of electrons and atomic nuclei. Just when everyone thought electrons were the tiniest entities in the universe, a German physicist enthusiastically announced that he had analyzed the composition of electrons. This scientist, named Jeroen van den Brink, was a condensed matter physicist at a German solid-state physics research institute. In 1996, Brink used a particle accelerator to smash electrons into their constituent particles. While particle accelerators may sound quite commonplace now, they were cutting-edge technology in the 1990s. The experimental principle was simple. Accelerate two streams of particles in opposite directions using electric and magnetic fields. Collide the particles, and observe the resulting outcomes. Although the method sounds straightforward, it demanded extremely high precision and accuracy from the instruments. Similar to cracking a walnut, 99.99% of the results were just a mess of particles and seemed useless. However, Brink's luck was exceptional. He aimed X-ray photons at electrons, causing them to split open. To his surprise, he found that electrons broke down into three distinct particles: holons, orbitons, and spinons. Brink stated that he knew these three particles were definitely not the smallest particles in the universe, so he was prepared to continue aiming at holons, orbitons, and spinons to see if he could separate out other particles. Physicists worldwide were now excited. Previously, particle accelerators had been used to study nuclear energy, but now they could be used to discover new particles. Consequently, renowned high-energy physics institutes worldwide hastily constructed particle accelerators. As a result, scientists have already discovered quarks, gluons, leptons, the Higgs boson, antiparticles, and more through these collisions. Of course, any of the particles mentioned above cannot be seen with the most advanced modern microscopes. The limit of what optical microscopes can see is around 200 nanometers, which is approximately the size of objects with a diameter of 0.2 micrometers, constrained by the wavelength of light. Electron microscopes use electrons with shorter wavelengths, replacing the light beam used in optical microscopes, enabling the resolution to be increased by more than 1,000 times. In other words, electron microscopes can roughly see objects with a diameter of 0.2 nanometers. However, it's not entirely accurate to say that these particles can be seen clearly. The imaging is often blurry and approximate. Currently, human technology can achieve imaging at the atomic level. For instance, lithium atom imaging under an electron microscope looks something like this. As for delving deeper into the microscopic realm, human imaging devices fall short. It is generally believed that atoms consist of atomic nuclei and electrons. How small is the atomic nucleus then? Its diameter is about 100,000th of the entire diameter of the atom. To put it into perspective, if an atom were the size of a large truck tire with a diameter of 1 meter, the atomic nucleus would only be about 0.1 millimeters in diameter, roughly equivalent to the thickness of a human hair. When your insight can delve into such microscopic scales, you will realize that at this level, there is also a vast space between atoms and atomic nuclei that can accommodate many things. Gluons, leptons, Higgs boson, and these entities exist at subatomic scales that are currently beyond the reach of human technology for direct imaging. Their existence can only be proven through various experiments and analyses by physicists. However, no matter how many particles are discovered, no physicist dares to guarantee unequivocally that these are the smallest particles. Physicist Michio Kaku summarized that what computer simulations produce are strings of zeros and ones, which constitute digital information. On the other hand, living organisms are composed of quantum entities. Quantum, also known as matter, is not just a form of information. It is detectable, measurable, and has mass, albeit in very small amounts. For example, consider a hydrogen atom with a mass of 1.67 times 10 to the power of -27 kilograms. Hydrogen is the most abundant element in the human body, constituting around 10% of an individual's body weight. Since the fundamental particles that make up the human body have mass, it becomes challenging to claim that this world is merely a simulation, right? The story that the world is a simulation fascinates some people because if the world is indeed a computer simulation, it must have a programmed code. In that case, those who study computer programming would be the closest to understanding the essence of the world. In the movie, The Matrix, the creators of the simulated world are called the architect, which resonates with the sense of superiority felt by programmers and tech-savvy individuals. It seems like it's the IT crowd who can thoroughly study and explain how this world came to be using our professional language of coding, programming, and simulation. However, IT guys simplify things too much. If this world truly is a creation of a programmer, the complexity of the program would far exceed imagination. How complex is it? The rules in the quantum world are vastly different from our world. Take, for example, the famous quantum physics experiment, the double-slit experiment. In this experiment, when the camera is turned on, the electrons shot from the electron gun through the slits leave two bright spots on the screen, exhibiting particle-like characteristics. However, when the camera is turned off, interference patterns appear on the screen, indicating wave-like behavior of electrons. This result is both fascinating and frightening. Does it imply that electrons have eyes and know when they are being observed? When you look at me, I behave like a particle. When you don't, I act like a wave. This result is quite mystical but hints at a direction where consciousness, as a form of energy, can interact with quantum entities. In other words, you could say that quantum entities themselves possess consciousness. So, when you compare the laws of the quantum world with the world we live in, they are vastly different, aren't they? It turns out that there have indeed been experiments conducted to verify this concept, known as the meditator experiment. Dean Radin, a parapsychologist, conducted a year-long experiment from 2012 to 2013. He recruited 137 participants, some experienced meditators and others regular individuals. They were divided into various groups for each session of the experiment, totaling 250 trials, in order to repeatedly verify and eliminate errors. During the experiment, participants were asked to meditate at the location of the double-slit experiment. The experimenters would command the participants to focus their attention on the double-slit interference experiment and then to shift their attention away every 30 seconds, repeating this process 40 times. The results revealed that when participants concentrated their attention on the double-slit interference experiment, the interference patterns on the screen produced by the electrons would weaken. However, when participants shifted their focus away, the patterns would strengthen. This indirectly confirms the connection between our consciousness and electrons, or even suggests that electrons themselves possess consciousness. This implies that our traditional division between what constitutes matter and consciousness might be incorrect. Therefore, as we delve into the realm of electrons and the particle world, known physical laws need to be reconsidered. Furthermore, when we move beyond electrons to smaller entities like holons, orbitons, and spinons, it's likely that a whole new set of physical rules govern that level of reality. If this universe was indeed crafted by a master programmer, the complexity of the layers of programs involved would be immense, with each level potentially governed by its own unique and intricate set of rules. The magnitude of this project far surpasses human understanding of programming. Physicist Michio Kaku paused for a moment and mysteriously said, "Although the simulation hypothesis, on the whole, may be wrong, there is one aspect in which it is right. Everything is definitely not evolved but created. There is indeed a creator in the universe, and it's very likely that there truly exists a code of creation. The creator is the most outstanding mathematician and physicist." Furthermore, Kaku emphasized that aliens may have interacted with humans in ancient times and influenced human civilizations, but they are definitely not the creators. They simply have more advanced technology, which humans admire. The creation of this universe is immensely complex, regardless of whether alien civilizations are 1,000,000 years or 1 billion years ahead of humanity. In comparison to the vastness of the creation project, their civilizations are not capable of such a task. So, what exactly is the code of creation? Kaku shrugged. We still don't know. We not only don't know, but also cannot describe it. Well, that's all for today's story. Thank you, everyone. If you found today's topic or this channel interesting, please consider subscribing and staying tuned for the next update. Until next time, stay curious and see you next time.